In this video, I'm going to be solving equations containing two radicals. I just want to say I forgot my mic. I'm out of town, so the sound may not be as good as it usually is. But anyway, we'll work with what we have. So we've solved equations, radical equations, that had one radical, and there were two things that we learned in doing that. Number one, you always want to isolate the radical on one side before you square each side to get rid of the radical. And then the other thing is we need to check our answers, because sometimes we're going to get answers that actually won't work in the original equation, and we can't always tell when that's going to be the case, so we have to check our answers. So when we solve equations containing two radicals, what we learn is we want our radicals to be on opposite sides before we square both sides. That's the easiest way to solve these. And so if you look at this problem here, the square root of 8x minus 7 equals the square root of 6x plus 3. This is actually quite an easy problem because all we need to do is square both sides and we'll get rid of the radicals and we end up with a very nice equation. 8x minus 7 equals 6x plus 3. And now I'm just trying to get x by itself, but I need to get x on one side first, so I'll subtract 6x on both sides. We get 2x minus 7 equals 3. Of course, this is a two-step equation. We'll want to add 7 to both sides first. We get 2x is 10, which means x is 5. Now remember, we want to make sure that we check our answers. And so I'm going to go ahead and plug the 5 back into the original equation. And what we get is the square root of 33 equals the square root of 33. And of course that's true, and so that answer does check. All right, let's move on to number 2. So this problem is more typical of what you would see when you're solving equations with two radicals. It turns out it's a little bit lengthy to solve these, and you'll see what I mean. So first of all, we want to get the radicals on opposite sides. So I'm going to go ahead and subtract the square root of x plus 5 from both sides. And so we get the square root of x minus 3 is equal to 4 minus the square root of x plus 5. So now we're going to square both sides, but when we square the left side, it's pretty nice because we're just going to get x minus 3. And when we square the right side, we got to be a little careful. Sometimes students will get something like this. 16 plus or minus, you maybe will make it a plus, and when you square x plus 5, you get just x plus 5. But it turns out you can't square those separately. You'll notice that, what we say about this technique, whatever you do to one side, you have to do to the other. We're squaring the whole side. That's why I used parentheses here. And so the thing is, when you do that, this is a situation where you're going to have to FOIL two binomials. So let me erase what I just did. And I'm going to go ahead and multiply this out off to the right. So again, we're going to need to FOIL out a binomial times a binomial. That's what that square is telling us to do. Multiply two of these guys. So 4 times 4 is 16. That's our first product. Our outer product is a minus 4 times the square root of x plus 5. Our inner product is also minus 4 times the square root of x plus 5. And our last product, square root of x plus 5 times square root of x plus 5, is just x plus 5. Notice you had a negative times a negative, so we don't have to mess with the signs there. It's going to be positive. But we do need to simplify here. We've got a 16 and a 5. That's 21. Notice we have two like radicals, a minus 4 square root of x plus 5 and another minus 4 square root of x plus 5. And so that's minus 8 square root of x plus 5. And then don't forget we still have that x there. And so I'm going to go ahead and plug this in. You'll notice I like to do this multiplication off to the side, and then I'll plug it into the equation. It just makes things look a little cleaner. And so now we're trying to solve this equation that has one radical. Well, remember, when we're dealing with solving an equation with one radical, we need to isolate that radical on one side and then square both sides. And so that's what we're going to do. So you can see we can subtract x on both sides, and we'll get rid of x. And also I'm going to subtract 21 to get rid of this 21 here. And so you get a negative 24 is equal to negative 8 times the square root of x plus 5. Now, again, we're trying to get the radical by itself. We've got negative 8 times the radical. Let's divide each side by negative 8, and we get 3 equals the square root of x plus 5. So finally, it looks like we'd like it, where we have the radical by itself, and this is actually a very simple one to solve. So let's square both sides. Of course, 3 squared is 9, and the square root of x plus 5 squared is just x plus 5. So we'll subtract 5 on both sides, and we get x is equal to 4. Last step, we want to make sure we check the problem. So let's plug 4 into the original equation. We get the square root of 1 plus the square root of 9 is 4. That's 1 plus 3 is 4, and of course that is true. And so that's a good solution. All right, let's move on. So this is pretty typical of what you would see certainly if you saw a problem like this on the test. I'm going to do one more example, and I would just warn you on this next one. There's one spot where it can kind of complicate things if you don't make a little adjustment. So I'll show you that. Let me go ahead and show you the problem. Excuse me, I got something stuck in my throat there. Excuse me. So we have the square root of 2x minus 5 is equal to 1 plus the square root of x minus 3. So notice this time the radicals are on opposite sides, so let's go ahead and square both sides. On the left, we're going to get 2x minus 5. And again, we have the same problem on the right. We're going to have to square this binomial, or multiply two of these guys. And this is a situation where we FOIL. Multiply our first terms, we get 1. The outer terms, we get square root of x minus 3. The inner product, we get the square root of x minus 3. And our last product, square root of x minus 3 times square root of x minus 3, is just x minus 3. We talked previously how if you take the square root of a number times the square root of the same number, you just get the number inside. That's all we're using here when we get this x minus 3. So let me erase that. Oops. And let's go ahead and simplify this. We can add the 1 and the negative 3 to get negative 2. We've got a couple of like radicals. Notice it's 1 square root of 3 and 1 square root of x minus 3, both x minus 3s. That's 2 square roots of x minus 3. And then don't forget the x again. And so let's go ahead and plug that into the equation. So again, once we get to this step, it's like, what do we do now? We need to get the radical by itself. So I need to get rid of this minus 2 and this x here, and maybe even the 2 here. Let's go ahead and get started. I'm going to subtract x on both sides, and let's add 2 to both sides. And so that'll get rid of those 2 terms that are not part of the radical. So we'll get x minus 3 is equal to 2 times the square root of x minus 3. So at this point, this is what I was talking about earlier. I could divide both sides by 2, and that would make things better on the right side. I would just be squaring the square root of x minus 3. But I really don't want to square a rational expression, and I can avoid doing that, and it actually makes things a little bit easier. So I'm not going to do that. I'm not going to divide by 2. I'm just going to go ahead and square right now. We're close enough that we can square both sides, and it's not very difficult. So let's go ahead and square each side. So on the left, we have x minus 3 quantity squared. Again, this is a FOIL situation. We've got to multiply out 2x minus 3's. So the first terms, we get x squared. Multiply the outer terms, you get minus 3x. The inner product is also minus 3x. And the last product is 9. And so we're going to get x squared minus 6x plus 9. And so let's go ahead and plug that in. On the right side, we got to square 2 times the square root of x minus 3. And this is actually not very difficult because it's all multiplication. Remember, we can multiply numbers in any order that we want. So let's multiply the 2's and let's multiply the radicals. We know we can multiply a square root times another square root. So 2 times 2 is 4. And we also know the square root of x minus 3 times the square root of x minus 3 is just x minus 3. Now keep in mind we're multiplying 4 by a binomial, so we do need parentheses here. So when we plug it in, it's going to be 4x minus 12. And so as you look at this equation, I see this x squared term, so I know this is quadratic. And so I'm thinking, all right, let's get 0 on one side, and we're hoping to factor the left side. If we couldn't do that, we'd have to turn to the quadratic formula or one of our other techniques for solving quadratic equations. Normally it's going to be factoring. So let's subtract 4x on both sides because I'm trying to get 0 on the right, and also add 12 to both sides. So we're going to get x squared minus 10x plus 21, and that's equal to 0. And this indeed does factor using the AC method quite easily. And it is a 1x squared, so this is pretty easy. I know it's going to be x in my binomials, and I just need two numbers that multiply to 21 and add to negative 10. That would be negative 3 and negative 7. And so we're going to get x is 3 and x is 7. So finally we got to remember to check our answers. And so we're going to plug 3 in. Going to see we have the square root of 1 equals 1 plus the square root of 0. That's 1 equals 1, which of course is true. Now I'm not going to verify that the 7 works, but it does. But again, you always want to check your answers. All right, so that's where I'm going to stop. And if you have any questions, let me know.